Good afternoon, Mr. Jeffrey. So I'm going to tell you about our bees model. The background of it is that in tissue engineering culture systems, a culture medium is used to soak the cells, and with soaking the cells, the cellular metabolism can occur, and that's how you have cellular growth within tissue engineered human cells. In this culture medium, it contains nutrients and other vitamins that's needed for cellular growth. And upon soaking the cells, the byproducts of metabolism are present in the waste culture, and this forms the waste culture. So we also realize that in cellular metabolism there is the production of collagen from skin, and we want to extract the collagen from this waste culture. So that is the whole point of our project here.
From the previous semester, we have done the media inner culture system, and we realized that the waste product is very rich in minerals and is very useful. Therefore, we come with this idea that extract the protein from the waste. This product actually can sell to the research center for tissue engineer and hospital because our product is biocompatible. And the budget of the project is 500, and we only use 1050 ringgit. The risk of our project is the time to get the materials and the leakage. So our project will start prototype at week 11, and week 12, and by week 13 the prototype has been done. And at week 14 we have done some test out and done improvement for the project.
So during the initiation phase of the project, we had to estimate the time and the cost that the project would entail. So to estimate the time, we came up with a Gantt chart, and that would be easier for us to see whether all the deliverables are met within that set period of time. We managed to follow the Gantt chart quite strictly, even though there was a bit of delay towards the end of the semester. And also to estimate the costs, we were given a budget of about 500 ringgit in order to complete the project, but then we only ended up using about 10 ringgit 50 cent. This is because we only spent 7 ringgit on the silicone sealant, and we spent 3 ringgit 50 cent on super glue. The other things incurred no cost because we managed to salvage them from the lab or use whatever that was available that we could find.
With regards to execution, what we did first was outline major tasks and then stipulate deadlines in which these tasks have to be completed by. We also created this linear responsibility chart in which you can clearly see the major tasks which have been outlined, and under which each group member is given a primary or secondary focus with regards to it. In accordance to our linear responsibility chart, our group leader, David, would ensure that all these deadlines are adhered to throughout the entire thing to ensure that our project was completed on time.
As for the controlling and monitoring section, we actually have to change the method of construction of the prototype. The reason for this is because our 3D printing was rejected by the deputy dean, and also a long waiting queue to use the machine. Prior to this setback, we actually did crashing to save time. According to the table, we actually crashed for 1 week, and the total increment was $10.50. So thus we overcame the time limitations.
So towards the end of the semester, for the closing, we reviewed our whole performance by frequent meetings, and then we checking back with tasks whether all the deliverables were met or not. And also we made some final adjustments, as in we tried to beautify the product. The rough edges were smoothed out using the grinders and sandpaper, and then some leakages were filled in using the silicone sealant. And also we beautified the fuse box as well so that it has better cable management. And also the quality was found to be up to par as to what was initially sought out to be. There was no leak, and the valves were working, and the pumps were working very well. So it was considered to be a success because all the objectives to make a proper functioning model were met by the fair.
In conclusion, as my teammates have already mentioned, the quality and functionality has gone better than expected. And a few recommendations for improvement is that we actually do more research on the extractor side, the filter, which probably is like nanofilters. We will also like to research more on a better way to roll out our melted PCl onto the system, as well as to collect more experimental data so that we have some more something to show in our research. Lastly, we would like to figure out a way to use the 3D printer, so we need to make our project smaller and design a few more functions so that we can use 3D printer.